first drone we're going to cover today is just a smaller drone. And the idea is just for you guys to just kind of see like what kind of technology we have, a variety of sizes, big and small, and then a variety of payloads as well. So you can see this one is called a Mavic 2 Enterprise, very small, very quick to deploy. So the idea is in 30 seconds to a minute, pull out the drone, unfold it, grab your controller, power them both on, and you're ready to roll. You can also mount some different payloads on the drone as well, like a spotlight, a speaker, a strobe light for night flight. And then some different capacities as well on these drones. So this one has the zoom capability. So if you're doing an inspection per se and don't want to necessarily fly close to the rail or close to obstacles, able to zoom in and get a better view. There's also a model available with a thermal camera, so you can get heat levels in certain areas. If you're doing, once again, this inspection, you see something overheating or an anomaly, both availabilities on the drones. Moving up into a mid-sized drone, we have Phantom 4s here that are connected to RTK. The multispectral drone here is used mainly in the agriculture and environmental monitoring. Think of invasive plant species or crop health. And then the one with the dedicated camera, the Phantom 4 RTK, is more in the construction space. So if you need precise measurements on whatever you're mapping or looking at with your drones, you have the ability to do so. Finally, the big boy in the corner there is the Matrice 200 series. And you have the ability to mount multiple cameras on there. And when you get bigger with your drone, you're able to improve the payloads as well. So the smaller drone here, we have 6x digital zoom, but on the larger drone, we're looking at 30x optical zoom. So really your payloads are increased, better resolution on the thermal, and then also the ability to mount other sensors such as methane gas detection, looking at pipelines, or a more complex multispectral sensor, or the ability to bring your own sensor to the table as well. You can also mount a sensor on top of the drone. If we're thinking like bridge inspections, you can fly underneath it and look up with that camera as well. And then finally, one step up, we get a little bit bigger, and for payload capacity there, you're able to carry more weight. So if you wanted to carry a package, or you wanted to carry another custom sensor that's weighing more, you have the ability to do so. So I hope this guy gives you a brief overview of kind of some of the ability of drones right now. You have battery life ranging from about 20 minutes to 35 minutes across these different drones, and range going up to over 5 miles. The #1 ferry operator in the world using drones for terminal inspections. So they autonomously have drones flying through their yards. They're able to look at the placard numbers on each of the terminals inside there. And they can inventory that so they know where each one is, and they don't have to have someone manually walk around and count that and put that into a program. They do have an operator standing by who can take control manually if they have some issue with their autonomous flight, but ultimately that's making that process faster and saving them money and saving a lot on fuel costs as well. Moving into the North Carolina Department of Transportation, they have a variety of use cases. First off, in their environmental analysis unit, they use drones to spray herbicide and pesticide on invasive species in their environmental areas. So you can attach tanks of solution to drones, including DJI drones, and they can spray the material in a pattern across a grid or spot spray as well. They're also using drones for environmental monitoring. Specifically when they have projects next to bodies of water, what they're able to do is they take the drones out on a boat, launch the drone from a boat, and by turning the camera angle straight down at 90 degrees, they're able to reduce the glare from the sun on the water and see health of vegetation that's in the water or around the water. So they do this before the construction happens and during to make sure that there isn't any negative effects going on. The aviation division will do inspections of their airports, looking at lighting, cracks in the runway, or any obstructions that may be growing, such as trees. We talked earlier about rail inspections, the ability to fly the drone down the rail line and stay in one spot, very advantageous. And then finally, interagency coordination. So if they have a severe event like a hurricane, there's often times where they're not able to get where they need to go. So having the eye in the sky and being able to quickly deploy that drone is very beneficial. And then a third and final use case here I want to do a little bit deeper dive into is accident reconstruction. And this is really one that makes a lot of sense all around for agencies to use. So the idea here is you have a major highway or even just a normal road that's being shut down due to an accident. After people are taken away and cared for, the accident remains, and oftentimes these scenes need to be documented. So the current way that a lot of agencies have done this or are doing it right now is called baselining. So they actually put a tape measure out on the ground next to their scene and then measure the distance from each of those articles they found to the baseline. And you do some math, Pythagorean theorem, and you're able to build a model after the fact. But ultimately, the takeaway is that's taking a couple hours. You're walking around on a shoulder of a busy road, so you're in a dangerous position. And then the data you get after the fact can be so-so. And then while you're taking all this time to make this model, traffic is backing up. That's increasing the likelihood of accidents happening, and then also taking dollars away from the region as people are losing money. That's where drones come in and can provide better data and do it a lot quicker. So you can see this is an incident here of a train derailment where Washington State Patrol was able to combine drones with on-ground laser scanners to build a dense 3D point cloud. They won't always use laser scanners on the ground because drones usually provide ample data, but in serious accidents or large-scale incidents, they'll combine the drones to get quality data of the top of everything on scene, and then the laser scanners to kind of get the nitty-gritty in between items. But they've seen significant cost savings and time reduction by deploying drones in the accident reconstruction space. And